Okay, we're back. Prime teacher while taking a pee break at the same time. Oh, dang. Well, I was also getting coffee. Terminal coffee, by the way.
Let's get ready to rumble!
Ready to rumble! Open boss.os. So then let's do something like let file.read fpath. Let's go file. We need to go let file is fpath dot file name of string value. Wasn't it like there's one that I thought there was one that you could do and you just skip V. Yeah. That can raise. Yep, that's the one we want. So cool. So we have we read the file or some error. So let's just go ahead and match. Or you can just do our result dot. Okay, whatever. Okay. Let's go ahead and contents. And let's just go ahead and print the contents out. We haven't actually written this file yet. So if we go to run T and we go to test Lua. Okay, and then we say print hello world. Nice. Okay, then each of these should be like this. And I wash my hands. True. That is one of the distinct differences. Look at this, Chad. Look at this. Nice. So this is going to let us... now we can try and read this file. Right? So all we want to do now is we just want to go... let parsed is equal to OCamLua parse. We're going to get a list of strings. Yep, we're going to do this. File here. Which we should fix these up shortly. And then do we have an OCamLua statement list. Statement list. Because where else are we doing this? We're doing this in parse. I want to turn that into yeah, so let's just go ahead and make a program is just a statement list, right? So we can just go ahead and go at the very top here. A program is statement list and here. Okay, and so then when we go back to here, we're going to go change two words program, which is good. And then we should be able to do print program as well, which is nice. So when we go back to our Lua AST here, we should get parsed, and then we should be able to go we should be able to go and we'll do OpenMLua as well. Parse ast.print program parsed. Oh yeah. Look at that, chat. Look at it. Now, I don't know if I can make this prettier at all. Right, but this, so now anytime I want to change this, right? Let's say I want to change this to also say print line 2. Right? Now we'll also get this statement. Local x is 5. Print x. Right? And then we just save this, and then it opens this up again. Right? Now this is, I still think we probably could have a nicer way of displaying this. You know what I mean? This is still not amazingly nice. I would not call this amazingly nice. You know what I'm saying? Oh, one thing I just noticed is this is holding extra stuff here. Huh. Nice. Well, good thing when we go back to here and we go to string, I actually don't, how can I discard these? We need to figure out how to discard this because we only want the inside part here. So I don't know how I discard them inside of OCaml. We'll just ask. In OCaml Lex, how to discard part of a regex match. Single string quotes? No, we haven't done that part yet either. We need to do proper string parsing. That part's kind of annoying and like in the unfun way. Skip blah as word. Adjust your regular instructions and capture groups accordingly. How to use a capture group to capture a double quoted string, but only the inside of the string. Really, that's the best part, is to do this. There's no way to do it without string.sub. That seems wrong. Got it. Okay. Okay. We'll need to confirm this later, but we can just go ahead and do this. Inside here. String of inside string. Nice. Well, this is good. I mean, this is like, this part's fine. Why is this not, why is this unhappy? Oh, these are other spots that need to get fixed. I see. These are the rest of my, because I have other spots where we had, it's not in here. Where is this? Expressions. Dune promote. We'll just promote these just to make sure. I don't know why that was confused before, but that's okay. Okay, nice. So this is kind of like the dumb way to do this, right? Because we can also do a similar idea here, which is we go here and then we say this. And then we go here. So we can check some escaped strings here, right? Print escaped. That's funny that OCamLua ignore. How do I turn off OCamLua ignore for a file? Oh, it's with a space. Okay. Start. But this doesn't know how to parse this because it doesn't know how to do comments. Okay. Nice. This skips simple line comments at least, which is fine. So it reads everything up to the end of the line after a double dash. We'll need to do this properly later, but it's okay. We could store comments or something, or we could do something different with them, but I just don't have any use for them right now. So now I have an escaped string here. That's great. So then we could go, no. We want still this to be like this though, right? And with this escaped. Okay. Which empty token. Oh, I think we did this wrong, right? Because this is going to say capture everything. No, this isn't right because this says anything that's not this. That's just wrong again, ChatGPT. Come on. Because this is saying I want to still accept these. I just don't. I want to skip them. This isn't right because it doesn't handle the escaped double quote character in the string. It should allow that and skip over it. Hello today. Probably what we should do is we could just go check what OCaml did. Or where was that other... Not OCaml LSP. Not this one. We'll get back to that later. Well, maybe we should pin this one because we might need this later. Conflicts here. Not this one. Yeah, so how did this do for the Lexer tokens? Where's an MLL Lexer ML here? String 1. Okay, so we can do both of these. These are the simple ones here. That's funny. This isn't properly right, but this is close enough. I'm going to steal this for right now because it's close enough for what we're trying to do. So let stir is this. String. We don't need either of these. We just want to take... So we want to go basically like this. Let quoted string is this. Delete surrounding here. Oops. Surrounding delete. I keep forgetting that. There we go. This in. And then we'll take this and go here. Now we can go here. Like this. Delete this. Okay. String. Quoted string is Lexing Lex buff. Then we can just delete all of these. And then we should have escaped. Wonderful. Wonderful, wonderful, wonderful. Not reading YouTube chat today? I did. Did I miss one? Doing recursive descent parser or using some shunting yard-based stuff? It'll be recursive descent, I'm pretty sure. What? Writing interpreted language and interpreted language. What do you mean? Like, OCaml's not really... like, OCaml's compiled. I don't know what... Like, I don't know what you're saying, Ferret. Okay. So that seems like that's working well. Nice. Okay, those are all good. Those all look good. I was thinking UTOP. Yeah, I mean it has ways to do stuff, but like it's not. Okay, sweet. So this is good. This is great here. We have this. So right now though, we don't have any way. OCaml is complicated. Sometimes, yeah, sometimes no. All right. So now what I really want to do is I would really like to Lua eval this. Then let's go OCamLua. Let's just call this Lua eval. Works better as a joke if previous one isn't already faded. Best it was already the fourth interpreter. Interesting. In order to compile, the compiler must first interpret the code. Lua eval ML. Okay, yep. We go to Lua AST. We can pretty much just copy this situation here. And then let's go ahead and also say in our test dune here, we're also going to do bin Lua eval. Okay, and then now we go to our run T file here, and we're gonna go down here and do Lua eval of this. And now we go back to eval. So instead of Lua eval, a // quote. I think it's good. It'll escape the. I mean, like it has to still be valid. We can try. I think that'll still work, right? Yeah, it's okay. It just puts a bunch of escapes in there. We don't need that one though. Okay, so now what I want to do, instead of parsing this, we're gonna do eval.eval program. We're really not ready for this because it's really not going to do anything yet. But then we have environment here. Module identifier table. Type T is this. At deriving show, I guess. So then we can do let format and T format dot P print string identifier table. This song makes it sound like you're doing some spy work on a mansion security suspicious. You're trying to leave sneakily. True. All right, so with this, what we can do is we can go back to our Lua eval here, and we can say end, I guess is fine. And so we'll go environment end. Cool. So we just don't have anything with no parent. That's fine. So what we want to do as we're evaling this program, which right now we're doing nothing with the statements. That's really not good. That's really not good. We can instead do something like ast.statement show statement. Thumped. All right, so now at least we're gonna print all of the statements here, which looks like this. Beautiful. Did you build your AST or using some blip? Well, we were using a library to help us with parsing, but we did all of the like lexing and parsing. Like we wrote everything for it. Writing OCaml on Hump Day, smart. It's a big brain strategy, chat. Okay, so this isn't really what we want to do, right? But let's just try and do something really simple where we put inside of the base environment. We use like, yeah, we're using Manir and we used OCaml. Yeah. So we have a statement here where we have some call and some expert list. Okay. Yeah, it's so cool. I'm gonna make a video about it for sure. Just even though I'm sure it's not gonna do that awesome because it's like the weirdest, most niche topic, I still want to do it because it's awesome. So we have some prefix expert, which we need to get the result of, right? So we have basically prefix, and we have args, right? And that's correct. Yeah, we have prefix and args. It's my color scheme. It's from Groove Buddy repo, and it's called, or it's from Color Buddy repo. It's called Groove Buddy. Next, you should do yak a C for extra headache. I think we'll probably skip that. So let's go. Let's prefix is eval expert prefix in here. So this should give us back a value, right? Do we have a way to so we have this prefix here. This should be a name. Oh, I see. This is some type here, right? We don't know how to get this. We need to look up what this name is. Eval expert. So we have something like name, right? Because this would be, we have a name. We have a name T. So we need to look up the name somehow in the environment. We can do a really simple one here, which would be name. With, can I not match against this? Maybe we should just call this string. And we say print. Tried to call print. Statement. Because what I thought would happen here is we should have a name for print as we're going through each of the statements. Eval statement. Oh, right. We haven't done this yet. We need to go eval statement and statement. That's what we haven't done yet. And. Oh, this should be, yeah, this should be ast.statement, just so that I don't. So this should be.
We should have used Elixir.
Function statement.
Ryan was right.
So true, though. Right? Function statement? Function name. Oh, no, not function statement. This is a call statement. Whoops. Call statement. Call statement. Nice. Tried to call print. Let's go! Meme done. I got you saying from Big Box Sui where he complimented me. Been on Manir versus Angstrom. I wonder how Angstrom's partial combinator feel. I feel like Manir has a lot of stuff that makes it really easy to parse a very complicated language. Angstrom seems harder. Dunked on. First off, he had to lie. Because he removed everything in my README. Where it shows that I've also made a transpiler for a Vim9 script. Which he didn't mention at all. It's not even a plugin, it's a compiler for NeoVim. So what's up with that? That's what I want to know. I don't understand. How? For humor. Okay. When we have print, so these are values. I need to have A value. A value is a function of string. Okay, well, string is just not a good. Phoenix LiveView 1.0 released. I didn't know it was not 1.0. I didn't even know. It's a lot of spinning. It's a lot of spinning wheels right here. Nice. Maybe I'll read this later. Release party. Okay, so a function. What is a function? A function is just something that takes a value list and returns a new value list. We don't have a concept really of multiple return values yet. So let's just say right now, this takes some t list and returns a new t, right? Ord cannot be derived for t list t. Oh, that makes sense. Whoops. In, magic, out. Okay. PPX deriving. Yo! Rocks are welcome. What were you up to today? I don't think I've ever seen you around here before. How's it going? We got to do something like this. At compare fun A B. Let's do compare address A. Ord cannot be compare. Oh, does it not work for particular? Oh, it probably doesn't work for particular ones inside of here. Do you have Rust and or Java experience? I've written some Rust, or I mean, I've written a good amount of Rust. I've written some Java, but a long time ago, not really anything. What was going on in Roxer's chat? What do you mean by Java? What's up with that? This part's kind of annoying. Oh, we could just say this, like Lua function. We can say callable, something like this. Lua func. We can't do this yet though. This part's kind of annoying. Okay. And Lua function, sig, and type T. Value T list to value T. Something like this. You just said one, Rust and what? I said I have some Java experience, not really. T2 SDE Linux distro. I don't know what that is. What is that? Oh, it's focused. Value
How
t.
would you say your mental focus is?
Let compare
Oh, it's
AB
focused.
is compare. It's kind of dumb, but it's whatever. Let show. Maybe it should also have a name. Optionally, it should have a name. I guess we should have. It should have an identifier, right? I guess then we should do. It's very confused now. This should be, I don't know, callback, impl. I don't know, something like this. It's whatever. Impl. Oops, this should go here. Sorry, I'm in the middle of trying to do something and I'm getting confused. Okay, nice. T2 SDE for all CPU architectures. Oh, dang, interesting. Oh, cool. T2 system development environment. Oh, sounds interesting. Nice. Fixing old drivers, working on piece. Oh, very cool. Nice. Kernel dev, nice. Did you finish C tutorial for Le Babies? I have not yet. We want to say deriving show or equals. It doesn't know how to do this, so we can do formatter. Oh yeah, we can go format and T is equal to identifier. Format and T like this, right? So we also need to do show. Let show T is identifier dot show T, and then equal. Let equal is AB is compare AB equals 0. What did it say here? Formatter int. Oh, right. T dot identifier. There we go. Beautiful. Okay, so now this should be Lua function.t, something like this. Lua function.t. And then hopefully this should be Lua. No. This one should be Lua function.t. Okay, we're close. Boom. Nice. Okay. Don't always use Professor Java. What's the value of the signature block above the struct? You have to do it if you're doing recursive modules. Basically, these modules depend on each other. You can also do some stuff where you hide implementation details and some other things like this. We're not doing this in this case. But because these modules, like, see how this Lua function is part of this value? Right? So it's like, you have Lua function, it's part of this, but Lua function also depends on value. So since these need to like recursively be able to talk to each other, you say what the signature is first, and then it like will wire up the signatures correctly, and then you show the implementation. Right? Because these types are all sort of like interwoven with each other here. JVM to native code compiler. I think JVM's probably pretty fast these days. All right, so when we go to print here, then what we can do is we can give this a function, right? So we could do something like let print function is value dot function. And then we probably want to go Lua function. I think, can we just go identifier? Identifier dot create. Do it. Get ID. And then impl is equal to some function with args. And what's it going to do? It's going to do nothing with them right now. It's just going to return nil. value.nil. Oh, right. Okay. So then what's this going to do when we eval this? It's going to return the print function. This is like really stupid right now, but that's okay for what we've got going on here. So now we have a print function. JVM mentioned. We're going to eval a statement here. How are we going to do this? We get to a statement and we get something here. So now we have a prefix. So if we have a call statement and we have a prefix here, then we're going to go prefix. Whoops. Dot. No, because we know what this is. We know that this is a value t, so it needs to evaluate to a function. Match prefix. Begin prefix with function. Lua func. Func.impl args. Ignore for right now. I don't know what we're gonna do with it. Fumped fail with could not prefix was not a function. I don't know. It's basically like trying to call nothing, right? Type expr list. Got it. Let args is list map args f eval expr. Unhandled expression. Unhandled expression. What are we doing here? These are exprs, so we have ASTP expr, something like this, right? Name is X. Oh, right. We don't know how to do this yet. So let's just not do this. Okay, nice. So now instead of printing the statements, where are we doing this for eval statements? I don't want to print these every time. Let's just go here. So now there's nothing. So what should we do? What should we do when we get our print function here? We're going to say args. We're going to go list iter args f funct percent a there's got to be like funct list.
I literally feel like I've just been doing it wrong. That's what I feel like.
I don't know how to do this yet, but we'll see. Did you quit your job? I did. Yeah, a while ago. Isn't it good to have an environment in the function too and evaluate the body? Yeah, we're going to get there. We're going to get there for sure. Everything needs an environment. We're going to have to do a bunch of stuff for this still, but we're doing basically the simple versions right now, right? And this is args are all expressions. So what are we going to do? We're going to print the expression, which is or value. Oh, chat. We made print. We made print. We made print. Fun employed. Okay, but instead of this being just pretty printing it, we actually need to implement what like printing actually does. So like let print value function. So we should have like value dot string stir. This should just be Pumped. Print. Formatter. Print. This should be formatter dot. That doesn't make sense. Why would this be? We can just do this for right now. Oh, right. Formatter dot. Oh no, it's just format dot pprint string. This should take. Oh, right. So then this should be. We might actually not want to pretty print it as a string. We'll have to see this in a sec. But this should be. Whoops. Instead of here, this should go print value. Oh. Chat. I mean, what happens if you do Lua print hello world? Just prints this. What happens if you do escaped? Oh, interesting. We need to get rid of this though. Okay, but we're pretty close. It doesn't really matter. I don't really care. I just don't really care. Yeah, I know it has an extra space. We have to do it like formed list with separator, blah blah. It's okay. It doesn't really matter. It's okay. It's okay. We'll sort that out. We'll sort that out like later. But this actually lets us like we're actually printing stuff here, right? So if we did hi and we did this, it should actually print both of these. Just like if you did Lua print H hello world. We're literally printing. Fumped dump dot list expr something like this. Yeah, we probably can do something like this. Yeah. Chat. Yes. 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 This is Lua. You know, we're running Lua right here. Like we have print kind of working. Now this is all, like I said, this is all wrong, right? In the sense that we don't have the right, like environments attached to these guys. We're not associating the right identifiers. We're not looking anything up. But what we are doing is we are actually running Lua code, pretend, with OCaml, right? And we can print stuff. So like if we did this value, and then we can go number, right? When float, where are my float utils? Maybe we should just open values. When float utils is int num. Oh, we got to do it. We actually got to do it this way. Match float utils dot is int num with I think it was true num. Then we're gonna do format pp int print fumped num false dot pprint float. So then we should be able to do print 5 and 5.01, something like this. Oh, baby. Oh, baby, baby. Oh, yeah. Doesn't this have, what type is this? Table, numbers. It needs an identifier. We'll make this into its own module as well, but that's fine. We'll wait for a sec. Oops. Right. Hodl chat. Hodl. We can print tables just like Lua does. just print it. I wonder if we did the form is not allowed to type of the inline record could escape.
Lab, coding through the night. His white paper's tight, ready to ignite. Haskell conference, the perfect place to shine. But when he hits submit, he sees decline. Big's heart sinks, motions start to fray. His code's a masterpiece, no room to sway. Rejected again, he can't understand why. Pig won't give up, he'll reach for the sky. Rejected God, it's just the start. Pigs pushing sanity, falling apart. Through the glitches and errors, he won't break. Pig won't stop, he's taking your mom on a date.
Dude, the ending is so sad. The ending of that song is so sad. What's up, Pick? Supreme Shrimp, job interview tomorrow? Good luck. Good luck. How do I... There's got to be a, like, print this as hex, right? This will never work though, because this is gonna have a different pointer value every time, which is funny. Which we don't really want to do anyways. It's just a bad idea. Oops. Pick, how sick though is this workflow? Are you seeing this? This is running the code and then we can check standard out. So I'm literally running what these things print to. 1, 2, 3. And then we can just we'll just update it. I'm feeling so good, dude. Feeling so good. And then it abruptly ended. I know, it's the end of the song. We generated that song. And then that was all the AI generated for us for pick. We can print the file and then we can see what this looks like, which is awesome. So we wrote our first function. That happens. Like, we wrote print. You know what I'm saying? Like, we wrote print. I don't know how we are going to write other functions. You know? We'll have to implement a bunch of the standard library, I guess, right? So it's like, if you think about doing like Lua equals math max or math, it's like, we'll need to implement all of these. But it's like, that's okay. They're pretty easy to make. We just have to write each one, you know? But that part, so that's cool. So then we can have like all the math functions. We would have all those. I don't know how far we'll go down doing that or not. Like, I'm not sure. I'm still sort of working out, trying to figure out like how far down that path do we want to go? We do need to figure out how we can do variables though. Variables are kind of important in programming language, I've heard. Crows, source, standard. What? Oh, maybe we can crowdsource. Got it. Yeah, it would be kind of, yeah, people could definitely write some if they wanted. I just don't know. I'm saying like from my perspective, I'm not sure exactly how far I want to take this. I'm having a bunch of fun learning how to do this for Lua. You know? But I'm not sure if I feel like, oh, I really need to be able to run like arbitrary Lua programs. I'm not sure yet. That part I haven't decided. It would be kind of fun to do like just like see how fast or slow it is for something. Like, how fast could it be on just a for loop, like adding a bunch of numbers? You know? We don't have this power yet, you know, but like local count is 0. And we do, you know, for I equals 1 to 100 do at, you know, or maybe even way bigger, like 1,000, right? Count is count plus I, print count, right? Which is like, okay. Seems a bit overwhelming to say, but syntax look beautiful. Oh, dude. It feels good. You know, how long does it take before it feels like it's taking any time to do something? Okay, there you go. That was the first time that I felt like it took it any time to do something. So it'd be kind of fun to figure out how do we do, and you know, how long would it take us to run this in OCaml here? Right? I don't know, because we're basically just writing a bad interpreter, right? How long would it take to just do some math? I'm not sure. Let's see. All right, I think I'm probably gonna go because I'm gonna go try and record some YouTube videos today. Just watch the next video.